right, pre-calc, we're going to dig right back into lesson 5.5. We're going to be right here on the top of your identity sheet. So we're going to be looking, or right here in the middle, we're going to be looking at power reducing and half angle formulas. The first part of my lesson today, I'm going to show you where those formulas come from. And so that's what we'll open up with, how to derive the formulas. So we start off with a double angle identity for cosine of 2 theta. So this is a double angle identity for cosine of 2 theta. What I'm going to do is I'm going to solve this formula for cosine squared. So what I'm going to do is add 1 over and then divide by 2. Now if I take that straight across and I take the square root of each side, then I'll have cosine theta equals plus or minus the square root of cosine of 2 theta plus 1 divided by 2. Now what we need to do is make that into a half angle identity. So in order to get a half angle, basically I'm going to take my angles here and divide them by 2. And so there's your first half angle identity for cosine. Okay. Now what we're going to do is derive the half angle identity for sine. So we're going to start off with another power reducing formula for cosine. We're going to use cosine 2 theta equals 1 minus 2 sine squared theta. All right, we're going to solve this one for sine squared theta. So I'm going to subtract 1 over. And divide by negative 2. Then I'm going to take it straight across and take the square root on both sides. And divide my angle by 2. So we'll have sine theta over 2 equals plus or minus the square root of 1 minus cosine theta divided by 2. And then we get into tangent. So if we want to find tangent squared of theta, and by the way, I should be circling these. These are identities as well. This is the power reducing formula for cosine squared. This is the power reducing formula for sine squared. So basically you've taken a squared function, cosine squared, and now you've written it back into cosine to the first power. Here we've taken sine squared and we've written it back as cosine to the first power. For tangent squared, we will stack sine squared over cosine squared. And once we do that, we'll have 1 minus cosine 2 theta over 1 plus the cosine of 2 theta. Now, if we want to take that and find the half angle, we would take the square root again, and we would cut every angle in half. Or you can look at it as taking the sine squared here divided by the sine of theta over 2 here divided by the cosine of theta over 2 here. So tangent of theta over 2 is going to be, let's see, if I put the square root over the square root, I'll have, let's see, the sine would be 1 minus cosine theta divided by 1 plus cosine of theta. Okay, so basically what I've done is I've taken this and I divided it by that, the radical would go over both the top and the bottom. So I have this one big ginormous radical. 1 minus cosine theta over 2 divided by cosine theta plus 1 over 2. That's going to clean up to that. Where did the pluses and minuses go? Well, they kind of canceled each other out. That's how I think about it. Now, if you look on your handout, you'll see on your identity sheet that they have two other versions. So they have these two versions. All right, so basically you have three representations for tangent theta over 2. You have this first one under the radical that I have in blue, and then you have these other two in green. In order to get from here to here, or here to here, you have to multiply either the top or the bottom by its conjugate, and then reduce and simplify. So for example, if I took 1 minus cosine of theta over 1 plus cosine of theta, and I just multiplied it by the conjugate of the denominator, I would have 1 minus cosine theta quantity squared over 1 minus cosine squared theta. And if I take the square root of the top, oh, we'll wait just a second here. Got sine squared theta there. If I take the square root, I'll have 1 minus cosine theta over sine theta. And so that's where this one is coming from. If I want to get this last green formula, I would change my conjugate here to 1 plus cosine theta over 1 plus cosine theta. All right, let me show you real quick how to use a power reducing formula, and then we'll practice for the rest of the notes on the half angle identities. Okay, if I have cosine squared of 2x and I want to use a power reducing formula, then I'm looking at cosine squared of u on my identity sheet, and cosine squared of u equals 1 plus cosine of 2u divided by 2. So that's the formula from my sheet. My u is represented by 2x. So wherever I see 2x, I'm going to pop it in right there. And that's all there is to it. All right, the next video is going to walk you through several examples on how to use the half angle identities. We'll do this first one two different ways so you can see its connection to lesson 5.4, and then I'll show you a few other examples like what you're going to see in your homework.